Chapter 2, Lesson 2, Part 2. Adding and subtracting numbers in scientific notation with different exponents. We'll have to add in an extra step here. Just like when we add or subtract fractions, when we have to make common denominators, we can't add or subtract scientific notation until we have the same exponents. So I'm going to show you how to do that next. So in this example here, we have town A with 3.8 times 10 to the 4th kilometers from town B, and town C is 9.2 times 10 to the 3rd kilometers from town B. So to find the distance between town C and town A, we would just simply add them together. But because we have different exponents, we can't do that. Again, we have a 4 here and a 3 here. So in order to do that, we need to rewrite 3.8 times 10 to the 4th using the exponent of the 3 instead. So we're going to move our decimal to the right one so we can drop that exponent down to a 3. So we get 38 times 10 to the 3rd now, plus 9.2 times 10 to the 3rd. And now we can just go in and add 38 and 9.2, where we get 47.2 times 10 to the 3rd. And again, we can't leave scientific notation that way, so we're going to move that decimal 1 to the left, which is where we get this 10 to the 1st power here. So 4.72 times 10 to the 4th power. So I know that can be a lot. We're definitely going to be doing some practice here. The same thing works with subtraction. How much further is town A from town B, or town A than town C? So 3.8 times 10 to the 4th minus 9.2 times 10 to the 3rd. Notice that they put the number here with a larger exponent first because it is just a larger number. That's where we can subtract. So again, we want to make 3.8 times 10 to the 4th as 38 times 10 to the 3rd by just moving that decimal place over 1. And then they do the subtraction, 38 minus 9.2. And you get 28.8 times 10 to the 3rd. And as you know, we can't leave it that way, so we're going to move our decimal over 1 space to the left. So now I have to include that 10 to the 1st power here. And I would get 2.88 times 10 to the 1st power plus the 3rd power. And I'd get 2.88 times 10 to the 4th power. All right, so let's do some practice because I know this can be a little bit overwhelming. So we have a rocket here. It has a cylindrical portion and then a cone shape. So the cylindrical portion has a volume of 9.6 times 10 to the 3rd cubic meters. And the cone shape group has a volume of 4.7 times 10 squared cubic meters. What is the total volume? So that tells me I'm going to add 9.6 times 10 cubed plus 4.7 times 10 squared. So I want to change 10 cubed into 10 squared, 9.6 times 10 cubed into something times 10 squared. So since I'm dropping my exponent by 1, since I'm dropping it down by 1, I'm going to move my decimal 1 space. So 96 times 10 squared. So now I can add these. 96 times 10 squared plus 4.7 times 10 squared. So I'm just now rewriting it using the distributive property. 96 plus 4.7 would be 100.7 times 10 squared. So now I need to rewrite it in scientific notation. I'll just fill this in I added. This time I'm moving my decimal 2 spaces to the right. So I'm going to have 10 squared. My exponent's 2. So 1.007 times 10 squared times the original 10 squared. So 1.007 times 10 squared plus the other squared would be 1.007 times 10 to the 4th meters cubed. Okay, so again, take your time when transitioning so that you have the same exponent to make sure you're moving it the right number of spaces. Okay, so in this example, in the past 2 years, Company A sold 7.9 times 10 to the fourth cars, and Company B sold 9.3 times 10 to the third cars. So how many did they sell to total in the past 2 years? So first I need to convert 7.9 times 10 to the fourth into something times 10 to the third. Since that 4 is going down by 1, I'm moving my decimal place by 1. So this is 79 times 10 to the third. So now I can add 79 times 10 to the third plus 9.3 times 10 to the third. Distributive property next, 79 plus 9.3 times 10 to the third. And I would get 88.3 times 10 to the third. I can't leave that here, so I'm moving my decimal one place to the left. So now I have 8.8 times 10, 8.83, times 10 to the 1 from moving that decimal on that original third. My product of powers property would make it 8.83 times 10 to the fourth. And I just noticed here in my instruction, it says round coefficients to the nearest tenth. So I would make this 8.8 times 10 to the fourth. And then in part B, it says how many more cars did A sell than Company B. So now I'm going to subtract 79 times 10 to the third minus 9.3 times 10 to the third. So 79 minus 9.3 times 10 to the third would simply equal 69.7 times 10 to the third. I'd move my decimal again, one space to the right, and I get 6.97 times 10 to the first times 10 to the third power. And I'm going to round here. Well, first I would get 6.97 times 10 to the fourth. And they say round to the tens place. Well, this 7 tells me it would go up. So that would actually make this 7 times 10 to the fourth power here. So all of these rules apply the same when we're dealing with the negative exponents or the really small numbers. Nothing changes except for maybe the direction we're moving our decimal in. So in this case, cell P occupies an area of 5.2 times 10 to the negative fifth, and cell Q an area of 5.1 times 10 to the negative sixth. What is the total area occupied? So in this case, we have 5.2 times 10 to the fifth plus 5.1 times 10 to the sixth. When we're dealing with negatives, we're actually going to make that digit higher, but it is a lower value. Remember, negative numbers move backwards. So to move this decimal over one space, 10 to the fifth, again, we're going down by 1. So it would be 52 times 10 to the sixth. Because they're negative numbers, it looks like the value is going up, but really it's going down. Remember, negative 6 is less than negative 5. So again, applying the distributive property, and I get 57.1 times 10 to the negative 6. They move this decimal back over 1 so that we include this 10 to the first power. 10 to the first power minus the sixth power is 5.71 times 10 to the negative fifth. Nothing different here at all, just dealing with negative numbers instead. In this example here, this is just the difference with the same numbers. Again, they change 5.2 times 10 to the negative fifth into 52 times 10 to the negative sixth. Then they subtracted, got 46.9, brought our decimal over one spot, so they had to include that 10 to the first power. 10 to the first minus the sixth makes it 10 to the fifth power. Nothing different at all. So let's try this one here. We have a page from a storybook with a thickness of 2.5 times 10 to the negative second centimeter, and a page from a dictionary of 5 times 10 to the negative third. Which book has a thicker page. How much thicker is the page? So they're asking for a comparison and then what is the difference? Okay, so again, the difference, we're going to start with our larger number here, 2.5 times 10 to the negative second minus 5 times 10 to the negative third. Okay, so now we need to change so that we have the same exponent. So we're going to drop 2.5 times 10 to the negative second down to 10 to the negative third. So because I'm going down by 1, I'm moving my decimal to the right 1 space. So it's 25 times 10 to the negative third. 25 times 10 to the negative third minus 5 times 10 to the negative third. Now you can use the distributive property, 25 minus 5 times 10 to the negative third. 25 minus 5 is, of course, 20 times 10 to the negative third. Now 20 is not scientific notation, so I'm moving this over here. I'm moving it to the left 1. So I have to add that 10 to the first power in. And now I'm going to use my product of powers property, 10 to the first minus the third, or plus a negative 3. So 2.0 times 10 to the negative squared power. So we said that the storybook, I'm just going to has the thicker page. That was the bigger number first. And it is 2.0 times 10 to the negative second centimeters thicker. All right, so another example here. An average size ant weighs approximately 2.5 times 10 to the negative third, and an average size aphid weighs 8 times 10 to the negative fourth grams. So find the sum. So we want to change 2.5 times 10 to the negative third to something times 10 to the negative fourth. So we're dropping down that exponent by 1. So we're going to move our decimal over 1 space. So this is 25 times 10 to the negative fourth. So now I can add those. 25 plus 8 times 10 to the negative fourth would equal 33 times 10 to the negative fourth. And I'd have to move that decimal over 1 space. So I get 3.3 times 10 to the first times 10 to the negative fourth, which simplifies all the way down to 3.3 times 10 to the negative third. So how much heavier is the aphid? So I would be doing, is the ant than the aphid. So I'd be doing subtraction here. 25 minus 8 times 10 to the negative fourth. Again, I'm skipping those first couple steps because I think you get the picture at this point. 25 minus 8 would be, drawing blank here, 17 times 10 to the negative fourth. I'm going to bring that decimal over 1 again, so I get 1.7 times 10 to the first power because I moved my decimal, times 10 to the negative fourth power, and I get 1.7 times 10 to the negative third power. All right, last part of this lesson is adding and subtracting numbers in different forms. So for example, if we had a number in standard form, like 480,000 times this number in scientific notation, 4.5 times 10 to the fourth, we're going to do something similar by just trying to get them both in scientific notation to the same power. So I would turn, I would turn 480,000 into scientific notation. So I'm moving a decimal 1, 2, 3, 4, 5. So I would get 4.8 times 10 to the fifth power here. And then I'm just going to follow my steps like I did in the last couple examples and get them to be the same exponent. So 4.8 times 10 to the fifth, I want to change it to 10 to the fourth. I'm bringing that exponent down by 1. So I'm moving my decimal over. So I get 48 times 10 to the fourth. I add them together. 52.5 times 10 to the fourth. I move my decimal to get it back in scientific notation, and I get 5.25 times 10 to the first times 10 to the fourth, which again simplifies all the way down, times 5.25 times 10 to the fifth. So just start out these problems by turning anything in standard form into scientific notation, and then go back and do what we did in the last lesson. The same works for subtraction. We had 4.8 times 10 to the fifth. Again, make it 48 times 10 to the fourth. Then do the subtraction to get 43.5 times 10 to the fourth. Move that decimal over. Don't forget to add in that 10 to the first power for moving the decimal over. And again, you get 4.3 times 10 to the fifth. I know I'm moving fast through these because you've practiced all these adding steps before. The only extra step was turning, again, that 480,000 into 4.8 times 10 to the fifth. So let's try this example here. The width of a nylon fiber is 1.3 micrometers, and the width of the synthetic fiber is 1.6 times 10 to the fifth meters. So which fiber has the greatest? So the width of a nylon fiber, we just have to remember that a micrometer, which they symbolize here, equals 1/1000th of a meter. So we'd have 1.3 times 1/1000th. Okay, so we're moving that decimal 1, 2, 3 places over. So we have 0.0013 meters, or 1.3. You know what? 1.3 times 10 to the negative. I'm sorry, I'm doing this all wrong. And I'm just going to say cancel this problem because they don't give us the conversion and I don't know it right off the top of my head. But we're going to practice as if this was 1.3 times 10 to the negative fourth, because I think that's what they have. So 1.3 times 10 to the negative fourth. So 1.3 times 10 to the negative fourth minus 1.6 times 10 to the negative fifth. So again, we're dropping this down. 1.3 times 10 to the negative fourth. We're going to move this over because we want to drop this one down by 1. So 13 times 10 to the negative fifth. So 13 times 10 to the negative fifth minus 1.6 times 10 to the negative fifth. I'm sorry for that confusion, but that would simply be 13 minus 1.6 times 10 to the negative fifth, which would be 11.4 times 10 to the negative fifth. I got to move my decimal over 1 to get it back in a scientific notation. 1.14 times 10 to the first times 10 to the negative fifth. 1.14 times 10 to the first minus the fifth would be 1.14 times 10 to the negative fourth power. Again, sorry for that confusion, but I just wanted to show you the steps there. So one last problem here in this section. So we want to find the total volume in liters of this order for glass cleaner. Ashley ordered 9.5 kiloliters, which I'm going to tell you is 9.5 times 10 to the fourth liters. Okay. And 3.5 of floor cleaner. So we want to add 9.5 to the fourth times 3.5 times 10 to the third. So again, I can't add because I have different exponents. So I need to bring this one down to 10 to the third, which means I'm moving my decimal over. So I have 95 times 10 to the third plus 3.5 times 10 to the third. I'm doing my adding of my coefficients here. with distributive property, I get 98.5 times 10 to the third. Got to move my decimal back over. So get 9.85 times 10 to the first times 10 to the third, which is 9.85 times 10 to the fourth. And they said round to the nearest tenth, so 9.9 times 10 to the fourth. All right, that's it for the lesson. I know this might seem a little bit overwhelming. Please just take your time and use your classmates as a resource for moving those decimals around and knowing which direction your exponent's going in. It will take some time to get it understood, but once you got it, it's really going to click and you'll be able to do it no problem. I'm sure you're doing just great.